Your transformations test is coming up. So what we're going to do is we're going to do what we can to prepare for it right now. Starting with number 1. The triangle ABC prime is the image of triangle ABC. Under which transformations will the triangles not be congruent? Well, they all preserve size. They all produce a congruent figure except for dilation. So which is the only one that will not be congruent? Dilation. I'm going to go through just the odds because I gave you basically 2 of each type of example. So I'm just going to go through one of each. They don't have time to practice. Triangle ABC is graphed on the set of axes below. Which transformation maps triangle ABC onto itself? Well, we have a song for this. Line of reflection equals line of symmetry. That's what we have to do here. These are all reflections. So if the line of reflection is a line of symmetry, then it will map it onto itself. So a reflection over the x-axis. Let's go through each choice. Is that a line of symmetry? No. X equals 2. Remember Yancey. Yancey has X-ray vision. X equals a number is a vertical line at 2. Is X equals 2 a line of symmetry? No. Y equals 2. Y equals a number is a horizontal line at 2. Is that a line of symmetry? Is that cutting the shape exactly in half? Yes. X equals -2. That's a vertical line at -2. Does that cut the shape exactly in half? No. Your answer would be choice 3. So, for reflections, line of reflection must equal the line of symmetry. And for rotations, the center of rotation must be the center of the shape. So let's just quickly take a look at that concept. For number 4, there's 2 rotations. There's one centered at the origin, and there's one centered at -3, -4. The origin is not the center of the shape, so that one cannot map it onto itself. -3, -4 is the center of the shape, so that one would map it onto itself. I'm not going to finish that problem off for you from there. I basically have the answer, but that's your concept, and we have our song to help us with that. That's a brand new song, so it's not on the YouTube channel yet. Maybe I'll try and get it on there soon. Who knows in the future when you'll hear this video again, if it saves a video. A regular octagon is rotated n degrees. Regular polygon. Min rotation is 360 over n. So when I'm rotating a regular polygon into itself, I use 360 over n to get the minimum rotation. An octagon is 8 sides. That's my minimum rotation. And any multiple of that, any multiple of 45 will also map it onto itself. Is 10 a multiple of 45? No. Is 150 a multiple of 45? No. Is 225 a multiple of 45? Yes. 45 times 5 is 225. Is 252 a multiple of 45? No. Choice 3 is your answer. So to find the minimum rotation to map a regular polygon onto itself, we do 360 divided by the number of sides. That's the minimum rotation. Any multiple of that will also map it onto itself. All right, number 7. I'm asked to identify the transformations. Whenever you're identifying the transformations, check for orientation. So, the small one, ABC, is going counterclockwise. The big one, ABC, is going counterclockwise. They're going in the same direction, so the orientation is the same. If the orientation is the same, it can't be reflection. Orientation is changed under a reflection. Everything else preserves it. So now we have to use a little bit of geometric common sense. They both have a dilation, which makes sense. I'm just going to erase those arrows at this point so it can look a little bit less cluttered. They're both being dilated. Is it a translation or is it a rotation? It's being rotated. It's being turned. So your answer would be choice 4. So when you're asked to identify the transformations, checking for orientation is very, very helpful. And again, the orientation is the order of the letters. Now we go into doing the actual transformations. L is 2, -3. M is 5, 1. N is 7, 3. Weird looking triangle, but doesn't really matter. It wants a translation 2 left and 4 up. To do a translation, we just count on the graph. If they want us to go 2 left and 4 up, I'm going to take each point. I'm going to go 2 left, 4 up. That's L prime. 2 left, 4 up. That's M prime. 2 left, 4 up. That's N prime. And that's it. Translation is one of the easiest things. You're literally just sliding each point on the graph. Number 10 is a second example of that. Number 11, I'm guessing, is something different. It wants a rotation of 270. So rotation is a turn. So to do a rotation, I'm physically going to turn my paper. Now, positive rotations are always counterclockwise to the left. So this would be 90, 180, 270. Now I'm going to write down the new coordinates. A prime is now 1, 2, 3. Let me just make it bigger. 1, 2, 3, 4, 5. -1, 2, 3, 4. 5, -4. B prime is +1, -2. And C prime is +3. 1, 2, 3, 4, 5, 6, 7. Now I turn back. And I plot those points. So I'm going to go 5, -4. That's A prime. B prime is 1, -2. C prime is 3, -7. And that's it. To do a rotation, rotate the point. You're always rotating it to the left. Each quarter is 90 degrees. 270 is 3/4. Once I get there, I just write down the new coordinates of the point, turn it back, and plot them. All right. Number 12 is another rotation. So number 13. In fact, let's do number 14 instead. Triangle ABC has coordinates, so let's plot those points. A is 2, 1. B is 6, 1. C is 5, 3. And it wants me to reflect over the line x = 4. Well, you need to know what x = 4 is. Yancey has X-ray vision. X equals a number's a vertical line at 4. So to reflect over a line, I count to what I'm reflecting over. If I didn't graph x = 4, I'm not going to get very far. So A is 2 to the right, so I go 2 more to the right, and A actually ends up landing on B. B, I have to go 2 to the left, so I go 2 more to the left, that lands on A. To get from C to the line of reflection, I'm going left 1, so I go left 1 more, that's C prime, and there it is. So for reflections, you count to what you're reflecting over. And again, if you want practice with any of these skills, you have a whole worksheet and a whole key on translations, on reflections, on rotations. You have plenty of examples with the key so you can practice whatever it is you need to practice. All right. Identify the transformation. Translate, rotate, reflect, check for orientation. Let's check for orientation. A, B, C, D, E, F. Same or different? Well, they're both going clockwise, so the orientation is the same. If the orientation is the same, it can't be a reflection, so it's going to have to be a rotation. So it wants me to put D, E, F onto A, B, C. So keep in mind I'm rotating it to the left. How many degrees is that going to be? I have the flat piece pointing up. I want the flat piece to point to face horizontally. That looks like 90 to me. So I'm going to rotate triangle DEF 90 degrees counterclockwise, centered at the origin. You need to be very specific with what you're doing. So I'm going to just erase that, and I'm going to do it. I'm going to rotate the paper 90 degrees. I'm going to list my new points. D is now -1, 3. E is now +3, +6. F is now +5, +3. I turn it back. I plot the points. That's D prime, E prime, F prime. I'm going to pause just to give everyone a moment to get caught up. All right, followed by now, how do I get that green DEF prime onto ABC? Well, you need to slide it. A translation. Now, how much, which direction? Pick a point, doesn't matter which one. I can either bring D to A, E to B, or F to C. I'll bring D to A. It's left 1, 2, 3, down 1, 2, 3, 4, 5, 6. A translation, left 3, and down 6. Identify the transformation, check for orientation to help you. If the orientation is the same, it can't be a reflection, it's going to probably be a rotation. If the orientation is different, it's got to be a reflection. Do the reflection or rotation, and then translate the rest of the way. Is this particular question asking if they're congruent? No, but for practice, let's just talk about what it would be if it did. If it said, are they congruent, then we state that it's a rigid motion. A rotation and translation are rigid motions. Tell me what that means. A rigid motion preserves size and angle measure, producing a congruent figure. So, let me just get rid of that same rotation that's upsetting me. Very upsetting. This particular question is not asking about congruence, but if it did, then you have to just put your steps 2 and 3, state that it's a rigid motion, a blank and blank are rigid motions, and then a rigid motion preserves size and angle measure, producing a congruent figure. The difference between steps 2 and 3 and just step 1, if it's just step 1, there's a 2-point question. If it includes steps 2 and 3, then it's a 4-point question. All right, let's skip that one. Let's do one off the grid. And because we did a rotation before, we'll do a reflection now. Identify the transformations. Translate, rotate, reflect, check for orientation. A, B, C, D, E, F. A, B, C is going clockwise. D, E, F is going counterclockwise. It has opposite orientation. If the orientation is different, then it must be a reflection. Now, when you're off the grid, you need to translate first. For a reflection, I need a side to touch. For a rotation, I need a point to touch. So what's the only side I can get to touch through a translation here? Well, I can get AC onto DEF. So if I slide this thing so that AC lands on DF, I'm just sliding it to the right, it's going to look like that. So what am I doing? I'm translating AC to DF. Once I have that, again, we said we had to do a reflection, followed by reflecting. What are we reflecting? Triangle ABC over line segment DF. You need to be very specific. I gave you a script in the front of your packet to follow. You can use the keys to follow that script as models, but you have to tell me what you're reflecting and what you're reflecting it over. You could have said AC, since AC is on top of DF. I don't think I ever wrote those actual letters in. A, C, D. You could say AC or DF, either one. And that gets it to map onto it. Is it asking about congruence? Yes. Explain why the triangles are congruent. State that it's a rigid motion. A translation and reflection are rigid motions. Tell me what that means. A rigid motion preserves size and angle measure, producing a congruent figure. No typos. Pretty awesome. On the grid and off the grid are very similar, but they are a bit different. Off the grid, you need to translate first. On the grid, it's easiest to translate last and just do the reflection and rotation first. Definitely practice them. If you don't practice them, it's going to be pretty hard to get full credit on these. But if you practice, you should be able to do it. 19. Triangle ABC is translated 5 units to the right and 40 units up. So if a translation happened, well, a translation's a rigid motion. And a rigid motion preserves size and angle measure, producing a congruent figure. So if a translation, rotation, or reflection happened, I don't care what it was translated, I don't care what it was rotated about, I don't care what was reflected over, my image must be congruent. So if angle A is 80, then A prime is 80. If angle C prime is 26, then angle C is 26. If BC is 5, BC prime is 5. And if AB is 2, or AB prime is 2, then AB is 2. If a rigid motion was performed, a reflection, a rotation, or a translation, then all the corresponding sides and angles are the same. It's asking for angle B. This goes back to the first unit. The angles of a triangle add to 180. So x plus 80 plus 26 equals 180. From there, I do the algebra. And I get 74. So if it says a reflection, rotation, or translation happened, I don't care about the details of them. I know that a congruent figure was created, so all the corresponding sides and angles must be the same. 20 is the same type of thing. That's it. Now on the test, I'm going to put some old topics on it most of the time. So I'm going to tell you exactly which old topics are going to be on there. So you're going to see complex triangle problems from the first unit. I gave you a couple of examples here. Again, they're on the key as well. But these are very, very important topics. And the reason I do this is because you're going to see this on the Regents. You're going to see it on the midterm. You're going to see it on the quarterly exam. So I want to make sure that you keep it fresh. The key for these problems is to look for triangles, look for linear pairs. So 21 in the diagram below of triangle ACD, blah, blah, blah. Triangle ADB is an equilateral triangle. You need to know when you see equilateral triangle, 60, 60, 60. No work to do. You can just fill in those angles as 60, 60, 60. Anything else important that it's giving us? Well, yes. It's telling us that DB is congruent to BC. Whenever you see two sides are congruent, mark the sides, mark the angles opposite them. So DB, BC, those angles must be congruent as well. Now, look for linear pairs, look for angles of a triangle. I see a linear pair at B. Whenever I have a linear pair, I subtract from 180 to find the other angle. So that's got to be 120. Look for angles of a triangle. I see triangle DBC. Since these have to be the same, x plus 120 equals 180. I do the algebra, because, you know, algebra's cool. 2x equals 60. X is 30. So that's 30. That's 30. Angle C is 30. So that's what's going to be on your exam. You're going to see a complex triangle problem. You're going to see a rigid motion question where you're finding a missing side or angle. You're going to see sequences of rigid motions on and off the grid. You're going to see reflections. You're going to see rotations. You're going to see translations. You're going to have to identify transformations by checking for orientation. You're going to have to map a regular polygon onto itself. 360 over n is the minimum. Any multiple of that will also map it onto itself. And you're going to have to map a shape onto itself. Center rotation. Oh, that's not right. Line of reflection equals line of symmetry. Center rotation equals center of shape. Practice. You have, oh, the one other thing, they all produce a congruent figure, except for dilation. Practice, you know exactly what's going to be on your exam, so practice, practice, practice. Use this video, use the key to the review sheet, use all the keys to all the lessons in the unit, put the time in, and kick some butt on your exam. Practice, practice, practice.